Hello YouTube, welcome back to the channel. So in today's tutorial we are going to go ahead and learn how to build a simple classification algorithm. So we're going to be building a machine learning project in which we're going to be able to predict the employee turnover, like whether an employee is going to leave a company or an employee is going to stay in a company, using different parameters and different features of that is collected in the data set. So this is going to be a very simple implementation. You're going to learn how to build do importing it of the data, do data pre-processing, be able to clean our data, creating variables for categorical variables, modeling with logistic regression and random forest, and at the end you are going to try to gain an accuracy in the logistic model to be around 70%, and then for the random forest we try to get around 79% or 78%. That's what you're trying to aim for. So we're going to learn also hyperparameter tuning and how to tune your models to get better accuracy and better result, and then after that to finally learn how to go ahead and save the model when you're simply done. Yeah, so this is what we're going to go ahead and do. So if you're new to the channel, please kindly consider subscribing, liking this video and sharing this content with anyone who you think might find it helpful. Again, if you're new to the channel, please hit the notification bell so that you can stay updated whenever I upload future videos on this. I also plan to make this to repeat the same tutorial using deep learning. So if you guys want me to make the tutorial on using deep learning, repeat the same project using deep learning, let me know in the comment section below. I'll do my best to implement that. Okay, so enough with the introduction and let's get started. Okay, so we're going to be using Google Colab. So I'm just going to go to another window, another tab right here. So on this tab I have a Google Colab opened, and I just created a file, and then simply you can go ahead, create a new notebook, and then you give it a simple name. I just gave it a predict of employee turnover tutorial. Okay, so the data set I'm going to be using is going to be I have the data set saved on my Google Drive, but I'm going to share the link with you, and it's going to be in the description of this video. Okay, so the first thing you're going to go ahead and do, we can give this a title. So I can just click a notebook here, and I can just click the cell and then write the title of this notebook. Again, if you're not familiar with what the notebook is, what Google Colab is, you can feel free to use Jupyter Notebook if you want, but I'm just going to be using Google Colab so that everybody can follow along, even if you don't have Jupyter Notebook installed on your machine. Okay, so if you can just go to colab.restart.google.com, and then you can get access to a Google Colab notebook. Okay, so once I have this done, what I'm going to go ahead and I'm going to give a title, and it's going to be called machine learning prediction. So machine learning prediction, just like that, machine learning prediction of employee turnover, just like this, employee turnover. So once we have this, what I'm going to go ahead, the first I'm going to go ahead and import the basic libraries that we need. So I'm going to click on this and then just say import the libraries that I want to use. So I'm going to go ahead and import those libraries. So import, I'm going to go ahead and import the libraries. So libraries, just like this. So once I have those libraries imported, I'm going to go ahead and once I have this written, I'm going to go ahead and actually import the libraries, and I'm going to import a couple of libraries. So I'm going to import pandas as PD. I'm going to go ahead and import numpy as NP. I'm going to go ahead and import Seaborn as SNS, so SNS, and I'm also going to say from matplotlib, right, from matplotlib.pyplot. I'm going to go ahead and import from matplotlib, right, I'm going to go ahead and import pyplot as PLT, just like that. So once I have this imported and everything done, I'm going to go ahead and load in the notebook, that the data set that I have. Okay, so I'm going to get this from my Google Drive, and the link to get this is this right here. So I'm going to copy this and simply go ahead and paste it right here. So paste it here. Okay, so now once we have this, is the link to the Google Drive documentation for the data set. So you can copy this and just simply go ahead, create a new tab here, and then simply hit enter there, and that should give you access to it. So you can see it's all here, the information for the data set is all here. Okay, so for you to be able to read something from Google Drive, then you also need to pass in this argument right here. Okay, so you have to say this argument and then plus the URL.split based on this, and then get the last two. Okay, the last one, the second one from the end. after splitting it. Okay, that's this basically means. So once we have this, I'm going to say df, and df is going to be pd.read underscore csv, right? So read csv, and I'm going to pass in the path here, and I can simply do a df dot head, just like that. So run that, and that should display for us the first 5 rows of our data set, which is this right here. So we can actually look at now, do some this explore data set. You can also do the df dot tail, which is going to return to the last 5 rows from the bottom, okay, which is this one right here. You can even go ahead and check the shape of the data set, which is going to return to us the number of columns and the number of rows that are in that data set. So I'm going to df dot shape, and then simply run that. So if I run this now, this should tell me that I have about 15,000 rows and 10 different columns. So I can do df dot columns to check those column names and to see what columns I have. So you can see I have these columns. So I have satisfaction level, the last evaluation level, the number of projects that the employee has done, the average monthly hour of that employee. So we can see there's a spelling right there in the month. Okay, there's also a time spent at the company, the amount of time that the employee spent at the company. We have work accident that the employee got at the company while working there. We have the left, like if he left the company or stayed. We have the promotion here, promotion the person, how many promotions the employee got in the last 5 years. We have the sales data, right, and then you have the salary of that specific employee. So once I have this, we have just take a quick look at that data. So I want to check the data if there's any missing. So I'm going to say is an A, and I'm going to try to get the sum. So if I run this, this should return to me the sum of missing values. So you can see we don't have any missing values in all those specific columns. So what I'm going to go here, I'm going to say df, and then I can say duplicated, and then I can just say keep, and I can say this to be equals to first. Okay, keep the first one, and then I can just do dot sum to check if you have any duplicates in our data set. So we have a couple of duplicates in our data set right there. So you can drop those duplicates if you want. So if you do not use we can also drop the duplicates, and to do that you can just simply say df dot drop underscore duplicates, duplicated, I think it's duplicates, and then go ahead and say input in place, and you say in place is going to be equals to true. Okay, so I'm going to drop it and then reassign the data back to df. That's what in place does. And then in here you can pass in a parameter called subset, and if you do not use the subset parameter, then all the values in the rows need to be the same to be identified as duplicates. So we have different rows here. We have the satisfaction level, the last evaluation, the employee projects, number of projects he has done. So you're going to delete all the rows in which all the column values are the same, right? Similarities. Okay, if you don't want to do that, you can say subset equals to false, and that also handles for you. So once we do that, I need to run this cell, and once I write the cell, I can just do a df dot shape, and then run that. So let's return to us the shape of our data set. So you can see we have this shape right here. Okay, so we have 100 and okay, that's 11,991 individual rows after dropping the duplicate, which is about 3,000 duplicates. Okay, so I can also do a df dot info and check the info about that data set. So you can do df dot info, and you can see I have the information right here. So I can have the data type, the name of the column, and then the counts. Okay, the null, none values right here. Okay, so once we have that, I'm going to go ahead and perform some exploratory data analysis to analyze our data. Okay, so the first thing I'm going to go ahead and do, I'm going to just make a markdown cell here. So I'm going to just make this and say exploratory data analysis. So explore data analysis. Okay, let's run that. So in explore data analysis, what I'm going to do, the first analysis that I want to perform is the monthly hour. So to do that, I'm still going to go ahead here, create another markdown cell, make this to be 3, and then we say monthly hours, like how many hours the employee spends in the office within each of those specific months. Okay, so I'm going to go ahead and say df, and I'm going to go ahead and get the month data, which is the average. We call it average underscore month. I remember this has a typo, so I'm just going to say average month like that, and then say hours. Okay, and I can do dot unique to check how many unique hours we have there. So dot unique, and and then just run that, and let's see what we get. So if I run that, we get all these values right here. Okay, so once I have that, I'm going to go ahead and plot this graph. So I'm going to simply go ahead and simply do a bin, and this is going to be equals to the length of the following. So I'm going to say length, and the length is going to be df, and I'm going to say the average monthly hour. So I'm going to simply copy it from here, copy it, and simply move it in here, and simply paste it in here, and then simply do get the number of bins you have. So you can say dot unique, and then run that. So this return to us the number of bins we have. So you can still do bins, and we can get that. Actually, it's actually okay. Let me call it bins instead of bins. Instead of bin, I'm going to say bins. So both of those variables, and then run that. So once I have this rain, I'm going to go ahead and simply plot this. Okay, so I'm going to be using a histogram for this. So if you want to use a histogram, you can simply do sns.hist plot. And once you do that, you can just keep 2 question mark, and that will give you the documentation of a histogram and how to plot graphs using histogram. Okay, so I'm just going to close that. We're going to go, I already have this done, so I'm just going to go ahead and type in the code here. So I'm going to do plt, I'm going to create a figure, a matplot figure. I'm going to say fig size, and the fig size is going to be equals to a tuple, which is going to be a 6 by 6 tuple, just like that. And once I have this, I'm going to do sns.hist plot, and I'm going to do data is going to be equals to our df, and I'm going to say x is going to be our x is going to be df, and I'm going to get the average month column. So I'm going to paste that over there, and I'm going to use KDE. I'm going to say KDE equals to true. So KDE stands for kernel density estimator, I think. Yeah, kernel density estimator. So once I have that, I'm going to do I'm going to say plt dot tight layout. So tight underscore layout. So tight layout helps to make the graph look better. So I'm going to plt dot show. Okay, let's press that. Okay, tight layout doesn't actually help to it kind of affects the appearance of the cell. Also get rid of some empty spaces, especially if you are going to export your notebook to a PDF document. Then it's good that you use the tight layout, just to make sure that the space around your graph is efficiently used and not just any randomly used. Okay, so you can see we have that plot right here. So you can see most people work around let me see, around monthly hours in the office works around, I think, 150 hours, around 150 hours are in the office. That's quite a huge number. And if people have 300 hours in the office, that's actually a big number, right? So some people work 150 hours, while others work 300 hours per month. That's a huge number, right? So other people work twice as much as others in the office. Okay, maybe those guys will get promoted, and maybe these guys who work 300 hours monthly will have more chance of being promoted than those guys who work 150 or 100 hours. Okay, so let's see more information about the graph. So now I want to go ahead and plot the number of projects that each employee has done. So I'm going to make this a markdown cell. I'm going to create a markdown cell here, and then this is going to be 3, and then this is going to be number of projects. So number of projects a person has done. So what I'm going to do is df, and then get the number of projects a person has done. So I'm going to simply say number underscore project, and number of projects project is going to be equals to I want to get the value underscore counts, and then let's see what we get. So let's try to get the value counts of a number of projects. So we have 4 projects, 3 projects, others have done 5, others have done 2 projects, others have 3, others have done 7 projects. Okay, so I want to go ahead and visualize this using a bar graph. Okay, so you can see the number of projects people are doing and its rate. So I'm just going to do plt dot figure, create a matplot figure. I'm going to say fig size, and fig size is going to be equals to the following. So I'm going to simply say 6 by 6, and then I'm going to simply do sns dot count plot, and then I'm going to simply say data, and data is going to be df, and then the x is going to be the number of projects that the person has done, and then I'm going to simply say plt dot title, and the title is going to be number of projects undertaken. Let's say undertaken taken rate. Let's just call it undertaking rate. I don't know, let's just call it like that. Give it any title you want, but as long as it makes sense. So we say plt dot tight underscore layout and then just close off that. I'm going to do plt dot show to show that okay, I got the spelling there wrong of show. Okay, so let me get the spelling of show here right. So show, show, just like that, and okay, show, and run that. So once we run this, now you can see we have the plot right here. So most people do around of 4 projects. Most people, that is mostly common, people doing 4 projects done by employees, and the least common is people doing 7 projects. Like nobody wants to do the hard work, right? So most people do around 4 projects, while less people, the number of people do 7 projects are the least. Okay, so mostly do 3 and then 4 and then 5 projects, and then 2 is the low, and then 7 is the lowest. Okay, even 6 is low. Okay, so most people do around 4 projects. So those people who do 4 projects, doesn't mean that they have a higher chance of promotion, or those guys who do 7 projects have a higher chance of promotion, or do they mean that they stay in the company longer, or all of that? And that's what we're going to be going ahead and try to that's the whole purpose of this data. So the observation is most people take around 3 to 4 projects, with 7 projects being the least undertaken number of projects, right? Great. Okay, now let's move on, and now I want to go and see promotions made in the last 5 years. Okay, so promotions made, and one thing you can do is you can compare the number of projects a person has done and the number of promotions that a person has done. Okay, that you can do that comparison if you want. Okay, so once I have that, I'm going to go ahead and create another markdown cell, and this is going to be 3, and this is going to be called promotion made in the last 5 years. So promotion made in the last 5 years, and what I'm going to go here and when we say df, I'm going to go ahead and get promotions underscore last underscore 5 years. Okay, promotion the last 5 years, and I'm going to get a value underscore counts, and then run that. So let's see the promotions that are made in the last. Okay, I got the spelling error. Let me see. It's actually promotion and not promotions. My bad for that error. Okay, let's run this again. So you can see that number of promotion people got promotion in the last 5 years. So most people didn't get promoted in the last 5 years. Only 203 people got promoted in the last 5 years. So 1 means the person got promoted, 0 means the person was not promoted. So you can see that most people weren't promoted, only 203 were promoted. Okay, yeah, that's the data, but it's actually a bit sad that in the last 5 years only few people got promoted, right? That's a bit difficult. Okay, so but that's the data that we have. Okay, so now I'm going to do labels, and labels is going to be df, and then simply get the label I want to want. So I want to see promotion. Let me go to make the type again. Promotion underscore last underscore 5 years, and then you're simply going to go ahead and do dot value underscore count. I want to visualize this value counts, and I'm going to say dot index, right? Get the index, and then I'm going to do dot to list to get Python list from out of it. So to labels, and if I draw it here, if I print it out, we can see we have labels. The person either got promoted or didn't get promoted, right? The labels are the values from here, yeah, which are the indexes, right? Okay, so once we have that, I'm going to simply say labels is going to be equals to I'm going to give it a name, because I don't want to be 1 and 0. I want to make it, if it's 0, then you say promoted. If it's 1, you say not promoted. That's what I want. So I'm going to say I'm going to create a list here. So I'm going to simply say promoted. I'm going to use a list comprehension. Promoted if I, right, is equals to 0, else not. We're going to say not promoted, and then for I in labels. Okay, so if the label if the value is equals to 1, you're going to say promoted, else is not going to be promoted. So basically what you want, right? Actually, if it is 1, right, if it is 1 is promoted, else it is not promoted. That's what I want. So I was once I have that, I can simply do labels right here and simply print that out, and that should tell me not promoted, which is 0, and promoted, which is 1, right? Okay, so once I have this, I can simply go ahead and do employee. So I'm going to use a pyplot here. So I'm going to simply say plt.figure, create a figure. You're going to get a fig size. So I'm going to fig size is going to be equals to a tuple or a tuple, whatever you call it. I think it's called a tuple and not a tuple. So I'm going to do plt.py. I'm going to have a pie chart. I'm going to simply pass in x, and x is going to be df, and I'm going to go ahead and get the data that I want. So I'm going to say promoted in the last 5 years, and then dot okay, this is going to be outside here. So dot value underscore counts, just like that. And I want to say the labels is going to be equals to the labels that we have, the labels variable we have up here. Okay, and then I'm going to simply say the auto pct, and this is going to be equals to the following, right? So it's going to be a string, and you're going to have the following. So we're going to have 1.2 f. You're going to format the percentage things to be two percentages, I believe. Yeah, to be 2 decimal places in the percentages, and you're going to simply pass in explode, because I want to explode. You can just actually leave explode for now. I'll just come back to it just in a second. So I'm going to do plt dot title, and I'm going to simply say promotion in the last 5 years, and then can do plt dot title layout. So plt dot title underscore layout, and then do plt dot show. Okay, plt dot show, and then run that. So once we run this, now this should okay, this graph is ridiculously huge. Okay, let's fix it and see what's wrong. Okay, I'm doing plt dot pie chart. So okay, let me see what's the error right here. So if I hover, it says that incomplete format, data frame of shape. What's the point here? Let's see. We have x equals to data frame, and then promotion, and get the values, and then the labels equals to the label, and then yeah, that's it. But I don't know why we are getting this error right here. What's the error? Let me see. View problem. There's view incomplete format. Let me just delete all that, and then just type it out one more. So I'm going to plt dot pie chart, right? I'm going to pass in x, and it's be df, and then simply promotion the last 5 years, and say dot value underscore counts, and then value counts, and I'm going to say labels is going to be equals to the labels we have, and then I'm going to say auto pct is going to be equals to the following, right? So I'm going to say percentage sign, so percentage right here, and then I'm going to say 1.2, and then f, and then okay, percent, and then once I have that done, I can yeah, that's basically it. So I'm just gonna close off this, close that off. So yeah, the error is gone probably. So good, now that error is gone, and the graph looks like this. So we can actually pass in also explode to explode this. So my error was here, right here. I didn't pass in 2 percentage signs, I just passed in 1. Okay, so I'm going to say explode, and explode, you can pass in how much you want to explode it. So the first, we're going to explode it by 0. The second one, we can explode it by 0.3, and let's run that again. Now exploding is just going to move this a bit aside, like separate from the general pie chart, right? So we can see that the number of people got promoted, only 16.9% people got promoted, 1.69% got promoted, while the rest 98.31% weren't promoted. So yeah, that's a bit of a sad story, but that's basically it. So you can see the observation is 98.31% of the people weren't promoted, of the employees weren't promoted. So are these employees going to be a turnover, or are they going to be staying in the company, or something like that? We can look at that in further details. Okay, also you can look at the number of people got promoted. We have 1.69 people got promoted, that they got another promoted. So are the people who are getting promotions likely to stay in the company or to have a turnover? That's, we can also analyze that more. Okay, so once we have this, I want to look at the number of work accidents that we had in the company, and to do this, I'm just going to go ahead and pass the following in, and I'm going to be work. Okay, let me just change that. So it's going to be work accidents, just like that. So work accident, what I'm going to do, I'm going to df, and then I'm going to go ahead and simply say work. This is actually capital W, so work underscore accident, and this is going to be we're going to get dot value underscore counts, and then let's print the work accident value count. So okay, the series has no value counts. Okay, it's value counts and not values count, sorry. Okay, so now once you have this, you can see that 0 means the person never had a work accident, and 1 means the person had a work accident. So you can see that a huge percentage of our employees, or the employee data set, or the employees net employee data set, didn't have a work accident, while only 1,850 had work accidents, right? So we can actually go ahead and try to visualize this even more and get more information. So I'm going to go ahead and use the similar approaches from here. So I'm going to copy this and simply paste it here, and then change this to be work underscore accident. Okay, and once I have this, I'm also going to go ahead and grab this part of the code, and once I have this part of the code, I can run this, and this part of the code I'm going to go down here and simply paste it here, and then this is going to be 1 means the person got a work accident, right? So we're going to say work accident, and then this is going to be no work accident. So you can say no work, just use no work accident, just like that. So run that. So once I run that, I can see we have those labels right here, and you're going to use this label to plot the graph. So I'm going to use a pie chart again. So I can simply go here, copy this code, bring it down here, and simply paste it again. And so once I have this pasted here, we need to change this to be this should be work underscore accident. Okay, accident, just like this, work accident. And I'm going to go ahead and simply change this to, in here is going to be work accident, just like that. And yeah, that's basically what I need to pass in here. Yeah, that's basically it, and I can simply go ahead and run this cell. So it's going to be the work accident that we have. So next list is going to be the work accident. So 84.57% of the people never had a work accident, while 15.43% of the employees had work accidents. So the number of people who had work accident doesn't mean they're going to stay in the company or they're going to leave and stuff like that. You can adjust all that. I think this exploding is a bit too big, so I'm going to change here to be 0.1, 0.3, and run that code again. Yeah, this looks perfectly fine. So yeah, that's basically it. So looking at this, you can tell the number of people who had work accidents and number who didn't have work accident, and how is work accident going to affect the employee the turnover rate. You can analyze all that. Okay, so now we have this. We're going to look at the time spent in the company, how much time they spent in the company. Okay, like time spent in the company working, okay, per day. Okay, so to do this, what is I'm going to do, this is going to be the number of years that the person worked in the company, right? So I'm going to do this simply just by creating a text cell above here, creating this, and you're going to simply say time spent in company. Okay, company, just like that, and run that cell. So once I have this, I'm going to go ahead and say df, and I'm going to say time underscore spent underscore company, and then simply do dot value underscore counts, and then simply run that. So once I run that, okay, I think I got the spelling of this wrong here. So time spent in the company, okay, spend, not spent, so the name is a bit confusing, but it's time spent in company. So the amount of time they spend in the company, right? It's supposed to be spent in company, but yeah, that's basically it. So what I want to go ahead and do here, I'm going to go ahead and get the labels. So to get the labels, I'm going to go ahead and just use the code from here, copy this, and simply go down here and simply paste it here, and this should be time underscore spend underscore company. So company, and this is the number of years that they spent working in the company. So run that, and you get the labels of the number of years. So you can have 3, 2, 4, 5, 6 years, 10 years, 7 years, and 8 years. So okay, so I'm going to go ahead and try to visualize it using a count plot, which is just going to be like kind of a histogram. So I'm going to do a plt dot I'm going to create a figure, and it's going to have a fig size. Fig size is going to be equals to a tuple, right? A tuple is going to be a 6 by 6 tuple, and then once I have it, I'm going to do a sns dot count plot, and I'm going to pass in x, and x is going to be time underscore spent company. So time that is spent in that company, and then I'm going to pass in the data, and the data is going to be df, right? And once I have this done, I'm simply going to go ahead and simply say plt dot title, and the title is going to be number of years spent working in the company, working in company. Okay, just like that. So one number of years spent working in the company, and once I have that, I can do a type layout. So I'm going to plt dot type underscore layout, just like this, and I'm going to do plt dot show and run that cell. So once I run this cell, okay, I got another error right here. So data is going to be, sorry, this is going to be a df, my bad, and then run that. So now you can see we have the graph right here. So you can see that most people spend around 3 years working in the company, at which point they turn off, right, they leave the company. Is for as we go to more and more years, the number of people reduce, right? So most people likely on average, like, you're going to spend around 3 to 4 years working in the company, and then you're likely to leave. Also, when we get an employee, a good prediction could be, okay, this guy could be here for like 3 to 4 years, and then he's gonna exit outright. But those guys who stay for 7, 8, 10 years, 6, 5 years are actually less and less and less as you go along. Okay, yeah. So you can also actually get the mean of the time spent, so you can get average of how long a person is gonna work in that company. So you can say spend company, and then you can simply do a dot mean here, and if I do dot mean and then run that, it's going to return to me the mean value, which is going to be 3.64 or 3.65 years. So a person is likely to stay in the company on average around 3.65 years, or around 3.4 years. Okay, so okay, once we have that, you can see that the observation that you can notice is that over 500 employees spent 3 years working in the company right here. Actually, exactly 3 years working in the company. Over 500 people work exactly 3 years in the company, at which point they turn off, right? They turn off, they leave the company. That's basically it. So once we have that, let's also go ahead and try to analyze which departments the different employees come from. So I can go ahead and make a mark down here, and this is going to be departments, right? Department and comparison, department comparison, just like this, and then run that. So once I run this, you can do df and then go ahead and grab the cells. Okay, the cells tell us which department they work for, and then they say dot unique, just like this, and simply run that. So if I run this, you can see we have the different cells right here, just like this. Okay, so once we have this, I'm going to simply do a df.cells. I'm going to go ahead and get the value count of each of the cells. So cells, and then do a value underscore counts, and just run that. So let's see how many value counts that we get for each of these. So I think the leading one is the sales. So we have most people working the sales department, and then the technical department, and then have the support department, the IT department, and then the least department is the management department. Okay, so let's go ahead and try to visualize this. So to visualize this, I'm going to go ahead and use the graph I'm going to be going ahead and using here is going to be I think we can just use a count plot for this, or you can also use a pie chart, but this is more than 5, and pie charts are only good for around 5 when you have 5 different variables or 5 different labels, but now we have more than 5, so we're just going to go ahead and use a count plot for this. So I can just go ahead and grab the code from here, so it's going to be very similar to this. Grab the code from here, then I'm going to go down here and simply paste it in here, and I can say department, the comparison, so number of employees per department, just like that. So number of employees per department, and this is going to be sales that we want. And yeah, that's basically it. So I can simply I can pass in the x. Let me just run this for now. Let's see how it looks. Okay, so now you can see this looks actually good, but one thing I noticed quickly, you can see this join right here. So let's actually try to rotate this to be at a 90-degree angle. So I'm just going to go up here, and I'm going to do plt.x right, x ticks, and then I'm going to simply say rotation is going to be equals to 90, and then run that. So once I run this, is going to return to me the rotate this to be at an angle of 90 degrees. So you can see the sales, the accounting department, the HR department, human resource department, the technical department, the support department, the IT. You can see all of them there. I think the least performing, the one that has the least number of employees is the management department. The one that has most employees is the sales department, right? Yeah, so that's basically it. So those are you can set different observations from here, and all of that. Okay, so now let's look at the the salary comparison of these employees. Like the salaries can be either high salary, medium salary, or low salary. So I want to see the number or the salaries from each of those categories. Like in most cases, which salary employee is getting, either a low salary, a high salary, or a medium salary. So that's what I'm interested in. So I'm going to say df, and then I'm going to say salary, and then I'm going to simply say dot unique, just like that, and simply go ahead and run that. So if I run this, it return to me either medium, high, and low. Okay, so once I have this, I'm going to say df, and then you can just go ahead and simply say salary, and then you can simply say dot value underscore counts, and then simply run that. So if you run this now, this should return to us the value, the different values. So you can see for the employees who are getting low salaries at the highest, and then medium, and then guys who are getting high salary at the lowest, while the ones who are getting low salary at the highest, right? So actually, let's go ahead and try to visualize this. So I'm going to go ahead and get the label, and to get the labels, I'm going to use the code we have been using, which is the code right here. So I'm going to copy this, drop down here, and simply go ahead, paste it here, and then run that. So you should get the labels. So once we have the labels, I want to use a pie chart. So we already drew a pie chart up here, so I'm just going to go ahead and grab the code for the pie chart, copy that code, move down here, and down here I'm just going to go ahead and paste it here, and then this should be this should be okay, this should be salary. So let me change the variables here. So it should be salary. Also here should be salary. This should be salary. Let me just copy all this and then change the title there to be salary category. Let's say call it salary category, just like that. And once I have this, I'm going to run these cells again, and that should run. Okay, I have an error right here of explode. Okay, we have more than one, so I can just remove this explode. We don't need that argument. So if you want to pass explode here, then you have to specify three different values. Currently we are only having 2 different values, right? That's why we are getting that error. But if you want, you can pass in and also another maybe 0.01 and then run it. Now it should be fine. You shouldn't get any error. So now you can see that's it. But I don't want the explode this time around, so I'm just going to leave the explode there and then run that. Okay, so the salary category, you can see that most employees are getting low salaries, and then we have high salaries, medium salaries, and then finally we have the low salaries. So around 47% of the employees are getting low salaries, while 43% were getting medium salaries, while only 8% were getting high salaries. Okay, so we have looked at that, and you can state the observation that you notice from this graph. Okay, so once we have that, that's basically it, what I wanted to go over on the data analysis part. Now you can see that you can compare this. One thing you can do is to compare. Okay, we're getting low salaries here. Depending on the salaries, are the employees either churning or staying back, right? You can do that comparison if you are interested in it, but in this case I'm not going to do that comparison. I'm just going to leave it as it is. Okay, so if you want to make a whole, because the analysis part, you can do a lot of analysis and you can take the whole time doing this data analysis. So if you guys want to make a separate video just analyzing this data, let me know in the comment section below. I will try to do my best to make a video on just analyzing the data itself. Okay, so once we look at that, I'm going to go ahead and begin the data processing part. So data pre-processing. So pre-processing. Oh, I hope that's the spelling of pre-processing. Okay, so once we have this, I'm going to get the certain values that I need right here. So I'm going to rename our data. So I'm going to simply say df, and I'm going to say dot rename. So I'm going to rename the data. So I'm going to rename, because when we're analyzing the data, I noticed a couple of things. So I'm going to say columns is going to be equals to, right? So I'm going to change the sales column to be called the department column. So we're going to call it department, right? Because that was the department in which the people worked in, and not where and not the sales actually, but the actual department in which they work. So department, just like that. And then you can say salary, and the salary is going to be equals to the following. So the salary is going to be salary underscore level level, just like that. And you can say space here. You can say in place, in place is going to be equals to true right here, and then simply run that. So that's going to rename our different columns. So the sales column now is going to be called the department column, and the salary column is going to be called the salary level. Okay, that's actually level, so let me get the spelling right. Okay, so once we have this there, you can simply go ahead and say df.columns and simply run that. So once we run this, to return to us all the individual columns that we have. Okay, so you can see the sales has been replaced to department, and then salary has been changed to salary level, right? It's a high level, a medium level, or a low level. Okay, so once I have that, I'm going to go ahead and do some categorical encoding right here. So for the salary can either be high, low, right? So it can be either high, low, or medium, right? And for the department, we have different departments. So I want to label encode those. I want to actually do label encoding for those, and for this I'm going to be using one hot encoding. Okay, so I'm going to use one hot encoding here. So I'm going to say I'm just going to call this categorical encoding, just like that. So in categorical encoding, what I'm going to go ahead and do, I'm going to say categorical underscore calls is going to be equals to the following, right? So I'm going to say department. So I'm going to say department, yeah, department and I also going to go ahead and also get the salary underscore level, just like that, and simply run that. So what I want to go ahead and do next is going to encode this. So I'm going to say encoded underscore calls, encoded columns is going to be equals to the following. So it's going to be equals to pd, right, pandas.get underscore dummies. So it's going to return to us the categorical value. So I'm going to go in here and pass in the categorical underscore calls. Okay, just like this, categorical calls, and then you can pass in the prefix. So I'm going to say prefix, and prefix is going to be called the cat. We're going to simply say cat, okay, or just categorical. So cat stands for categorical. So it will be categorical underscore sales department, cat underscore TIT department, and stuff like that. So run this, and okay, we have the it's not okay. So we call this salary level, salary level. So copy that and paste it here. Okay, why are we getting that error? So let's see, it says salary level is not in axis. So okay, let's see where I made a mistake. So the prefix is going to be this, and then you're going to pass in pd.get dummies, right? We pass in our data frame and then the categorical values, and then we just say prefix is going to be cat. So salary level is not in. Okay, okay, the reason why this happened is because I have to go ahead and change when I did the first time, I did a typo. I forgot the L at the end of level. That's why we got that error, but now we change it back to level, so now it should be all fine. So yeah, that's the point of that error. So now if I run it here again, now hopefully that error should be gone. So we can do the encoding, encoded underscore calls, run that. So once I have this one, you can see we have the encoded values right here. Okay, so one way we can solve this error which we are having up here is by running the whole cell again, yeah, so that you can have the default column names. Okay, but for me I did an error earlier on, that's why the column name already changed. So I was trying to change the column name that does not exist anymore, that's why I'm getting that error. Okay, so once we have this, what I want to go ahead and do is actually join these the two data sets that I have. So just go ahead and do the following. So I'm going to minimize this, and I'm going to go ahead and say encoded underscore calls dot I'm going to actually say df is going to be equals to df dot join, right? Df dot join. I'm going to say encoded calls, just like that, and simply run this, and I'm going to df dot head and then run that. Okay, so once I run this, that should return to us an output, and yeah, this is the output where you can see we have the different columns. Okay, let me just okay, if I just carefully scroll, you can see we have the categorical columns: cat, HR, cat, marketing, cat, production management department, cat, sales department, IT support department, and all that. Okay, and for the salary, we have category for the low salary, we have category for the medium salary, we have category for the high salary as well. Okay, So once we have done those categories, I don't need the other values anymore, so I can simply go ahead and simply drop those values which I already encoded, right? So we can drop those later on, but for now we can actually drop them. So because they are still in here, so we can actually drop the departments and also drop the cells because we don't need them anymore. So we can say df dot drop, and then you can pass in a list here. We want to drop the department and the value from the cells. No, it's actually, yeah, the cells, and I think it's called cell or cells. Let's look. It's called cells, and then you can just say in place equals to true, and say in place equals to true, just like that, and run that. Okay, not found on axis, so I have to specify which axis this was. So axis is going to be the column axis, so column, just like that, and run that. Axis name columns, let me see, is it columns or columns? So I think it's columns. Let's try again. So cells not found on axis. Let me see, the cells column should be found on axis. We changed the cell name to be department, sorry, my bad. So it should be department, and the other one is the level, salary level. So those are my two errors. So I'm going to change that to be salary level, and then run the code again. So once I run the code, now everything should be perfect. So we have dropped those columns. So if I do df.shape or df.columns, let me just do df.columns to see if you get those columns there. So you shouldn't have this department column, and you shouldn't have the salary level column, okay, because you have encoded all of those into these specific different variables. Okay, so once I have that done, I'm going to simply go ahead and what can I do again? Okay, so the next thing we can go ahead and do is actually do a min max scaler. We can use a min max scaler if you want, and min max scaler can improve the accuracy of your model, because if, for example, if I just grab some columns, so if I do df, let me just make this a background cell here, and I'm just going to make it 3, and it's going to be min max scaling. So min max scaling is going to be equals to the following. So it's going to be equals to df, and then you're going to say average monthly hours, right? You can get the mean average monthly hour. You can do dot mean right here, so mean, and then run that. You can also do the mean average hour, the max of it, and then put it here, and then just simply say max, and then run that. So once you have this, you can say this is the mean and this is the max. So these are very huge values, so you can use min max scaling on this and to see how the model performs. But in my case, I'm not going to be using min max scaling on this, because I find the model does actually really well without the min max scaler. But if you want, you can try it out and see how the model performs. Okay, so now once I have this down there, I'm going to go ahead and do splitting our data. So I'm going to say split data into the train and test. Split the data into train and test. So run that. So what I'm going to go ahead and do here, I'm going to simply say x, and it's going to be equals to df.drop, and just go ahead and say the following. So I'm going to simply say drop the left. I'm going to drop the left, and I'm going to say axis is going to be equals to 1, like if the person left the company or not. That's going to be our x, and our y is going to be equals to the following. It's going to be df and then left, just like that. Run that. So the x is going to be everything except the left, while the y is going to be just the left. So I can do ahead and then let's run that. You can see the whole data frame except whether the person left the company or not, because that's what you're trying to predict, right? Okay, and you can also do y dot head, and you should also get that something back here. So if I do y dot head and run that, we should also get back the value right here. 1 means the person left, 0 means the person, or the employee in this case, stayed. Okay, so once we have that done, I'm going to go ahead and split my data now into x and training and testing sets. So I'm going to say from sklearn dot model selection dot model underscore selection. Okay, I have to type this out, selection, import the train underscore test underscore split, and then run that. So I'm going to import the train test split, and I'm going to simply say x underscore train x underscore test comma y underscore train comma y underscore test is going to be equals to the train underscore test test underscore split, and you're going to pass in here x comma y, and you're going to simply say train underscore size is going to be equals to 0.8. You're going to use 80% for training, while the rest 20% you're going to be using it for testing our model. So you can say x underscore train dot shape to check the shape out, the shape. So it's going to be 9,900 and okay, let me get this right. It's 9,592 92 rows for training, while the rest is going to be used for testing. So I'm going to do x underscore test dot shape, and then you can check. You're going to use 2,399 for testing, right, for testing our model. So once we have this done, let's go ahead and begin to train our model. Okay, so we're going to simply say train model, and to train the model, what you're going to have two models: a logistic regression model and a random forest model. So for the logistic regression model, what I'm going to go ahead and do, I'm going to go ahead and just create a markdown here. I'm going to simply say it's going to be logistic regression model. So feel free to use any classification models that you want to use, but I'm just going to be using this classification model. So I'm going to say from Scikit-learn dot linear models, so dot linear underscore models model, import the logistic regression model. So the logistic logistic regression, and I'm also going to say from Scikit-learn dot matrix matrix right here, matrix. I'm going to go ahead and import the function. So I'm going to say accuracy underscore score. I'm going to import the classification score. So I'm going to say classification report, and I'm also going to import the confusion matrix. So confusion matrix right there. Okay, so once I have this imported, I'm going to go ahead and create a logistic regression model. So a logistic reg model is going to be equals to logistic regression model, and then simply pass in the max underscore iteration. So I'm going to pass in the max iteration. You can pass in other values if you want, but I'm just going to pass in max iteration to be around yeah, let's just leave it to be this value, which is about 20. Okay, let's leave it to be 2000. It's fine, and then simply run this. The reason why we're going to be introducing the number of iterations is because we didn't scale our data. So if you scale your data, then you don't have to pass in the number of iterations, but in this case, since we didn't save a number of, we didn't scale our data, so we're going to be using max iterations right here. Okay, so once I have this logistic regression, I'm simply going to go ahead and do a simple fit on this. I'm going to fit it on using the X train and then the Y train. Okay, and then simply run this. So once I run this, it's going to return to me the model right here. The model has been trained already, so we can begin actually to make predictions. I'm going to say log reg underscore predictions is going to be equals to log reg dot predict, just like that, and pass in the x underscore test, just like that, x underscore test. Let me get that spelling right. So once I have this, I can simply run the code, and it should return to us a different predictions. Once you have the prediction, you can check the accuracy of the model. So you can say accuracy score, right? It's going to pass in the correct answers, which is going to be the Y test, and the predictions from the model, which is called the log reg predictions. Okay, log reg predictions right here, and simply run that. So we're going to get the accuracy of our model. So we got an accuracy of around 83% accuracy of our model, right, which was more than the 77% that we set for ourselves earlier on. So using logistic regression, you're able to get an accuracy of around 84%. Okay, sorry, 83%. So once we have this, I'm going to go ahead and print the classification report to check what is the recall, the precision, and all that information. I can get it by here. So I'm going to simply say y underscore test, and I'm going to say log reg, and then log reg underscore prediction, just like this. So log reg predictions, and that should be done. That's basically what we need, and you can run the code right there. So it says log reg predictions. Okay, no prediction. Okay, let's run that again. So you can see we have the output here. So we have the recall, the precision. So the precision for the truth classification has a lower precision. So it also has a lower recall, and also has a lower F1 score, right? Okay, the reason is because most people were actually having a high turnover at the company, so that's why we're getting that. So it looks like our data is imbalanced. Our model is suffering from a situation of data imbalancing. Okay, so once I have this done, we can go ahead and actually look at the confusion matrix that we want. So I can actually go ahead and create a confusion matrix here, and the confusion matrix is going to be confusion underscore matrix, right? I'm going to pass in the y underscore test, and I'm going to pass in the log reg underscore prediction, just predictions, and then let's see what confusion matrix is. Okay, let's print out the confusion matrix, and this is the confusion matrix right here. So I want to go ahead and try to visualize this confusion matrix. So I'm going to do a plt dot figure, and then I'm going to simply say fig size. So fig size, and the fig size is going to be equals to the following. So we're going to say 10 by 6. Okay, let's say 10 by 6, and then I'm going to say sns dot heat map confusion matrix, and say a not is going to be equals to true, just like that. So once I have this, I can do a plt dot a not equals going to be true, and then I'm going to do a plt dot tight layout. Let's give it a tight layout, and let's do a plt dot show, just like that, and simply run the code. So once you run it, this is now the graph that we get. So you can see our model is actually doing poor when it comes to predicting one value. So it's getting a huge number of it wrong here, while it's doing well while trying to predict for only 75% of the time it got an accurate prediction for 1. For the rest of the time it predicted 1 to be 0, which is wrong. Only 75% it predicted 1 to be 1, right? So now that we have plotted the graph for the heat map right here, so you can see our mod, it is the interpretation. So for it predicted 0, right, to be 0 this amount of times, right? So this amount of times it predicted 0 to be 0, which is correct, right? And for this 90 times it predicted 1, while the correct answer was 0, right? That's the issue. And for this amount of time it predicted the true answer was 1, but our model predicted 0, which was wrong. So these are misclassifications. So this on the other diagonal are misclassifications, while this on the main diagonal are the correct classifications. So for 75% of the time, for 75 times it predicted 1, while the label was actually 1. So it predicted 1 and the label was 1. So the truth was 1 and our model predicted 1 75 times. Okay, so our model is actually doing bad when it comes to predicting 1. So we are suffering from an issue of unbalanced data sets. Okay, so I've explained what all this confusion matrix is, how you can use, how you can analyze it, and I'm going to leave the link to the video. I can keep it as a card. If I don't, then you can find it on my channel's main page, where I went over and explained what is a F1 score, what is recall, how to interpret classification reports, how to interpret confusion matrix and or heat maps and all of that. Okay, so I'm not going to go into depth about that much. Okay, so once that's all about for the logistic model, the logistic regression model. So now I'm going to move on to the random forest. So I'm going to say random forest, just like that. So random forest, and in random forest, what I'm going to go ahead and import a couple of things. I'm going to say from Scikit-learn dot ensemble. I'm going to go ahead and import random forest classifier. Okay, random forest classifier, just import that, and I can simply run the code right there, random forest classifier code. And once I have this, I'm going to say run forest is going to be equals to the random forest classifier, and then you can pass the number of estimators that you want. So number of estimators, so the number of trees that our random forest will have. And if you are a complete beginner, I don't know what a random forest is, I have a whole tutorial explaining what random forest is. even if you don't know what logistic regression is, I have a tutorial explaining the basics of logistic regression and random forest, all in my machine introduction to machine learning series on my YouTube main page. Okay, so you can check that on the channel's main page. So once I've created an instance of that, now I'm going to go ahead and train the, so I'm going to say random forest and you're simply going to go ahead and say .fit, and you're going to pass in the xtrain comma y underscore train, just like that, and simply run the code. So once I run the code now, we should get our model being already trained. So we can go ahead and simply do try to get a prediction. So we say random run forest underscore prediction is going to be run forest prediction is going to be equals to run forest dot predict, right? Run forest dot predict, and what you're going to predict, you're going to pass in x test to try to predict the x test values, and then run that. So once I do that, I'm going to check the accuracy of this. So I'm going to say accuracy underscore score is going to be equals to, you're going to pass in the truth values, you're going to be the y test, and then the prediction is going to be the random forests underscore predictions, and then run that. So this return to us the accuracy of this. So the accuracy is a 98.4% accuracy. So you can also print the classification report if you want. So I'm going to go ahead, grab the code from here, move down here, and simply paste it down here, and this should be classification report. So I'll copy that and paste it here, and simply okay, I didn't error there. So let me just grab that properly. So I'm going to copy this and then paste it here, and then no, I want to select all of this cell and then paste it here and run that. So once I run now this, you can see the classification report right here. So now you can see the random forest is doing better in terms of the precision, the recall, the F1 score for the one class, for the class where the prediction is 1, right? And you can compare to the class, the one that it was doing 14, 19, 26. Now here is doing precision was 99, 92, 98. So you can see random forest is doing way more superior than the logistic regression classifier that you are using. So great, you can go ahead and try to train other classifiers if you want, and that should get more information on which classifier is best for this. But I think random forest, from my research, I have done some models, and I see random forest is best for this. So I'm just going to keep it random forest just to keep the tutorial simple and short, not too long. Okay, so I'm going to say run forests predictions. So I'm going to get run forest predictions right here, and then simply run this. So I'm going to run that, and I'm going to get the random forest predictions right here. Okay, good. Okay, so once I have this done, I can actually visualize it if I want. So I can do plt.figure, and I'm going to pass in the fig size, and the fig size is going to be equals to a tuple or a tuple, whatever you call it. It's going to be 6. This is going to be 6 instead of 5, so 6. And then you can do sns.heat map, and I can do passing the coefficient matrix, and then say a not equals to true, and then simply do a not equals to true, and then simply go ahead and do a plt.tight underscore layout, and then I can do plt.show, just like that, and run the code. So now this is going to run the code, and it's going to return to us the graph right here. So comparing this coefficient matrix with this the heat map coefficient matrix, just visualize. So we can comparing this heat map with this heat map that we have here. You can just right off notice the random the significance improvement that we have. So for 200 and something times, right? For 2000 times, the actual prediction was 0, and our model predicted 0, which was correct. So for 2000 times, our model was correct. And for this is about 300 or something times, 370 times, our model predicted 1, right, while the true answer was 1. So this is also correct. So 300 times it made a correct prediction when predicting 1, and when it comes to 0, it made a wrong prediction 4 times. So the answer was the truth was 0, but our model predicted 1 4 times. And in here the truth was 1, but our model predicted 0 32 times, which was the wrong classification. So this on this diagonal are called the misclassifications, while these ones are the correct classifications. So you can see our random forest model is doing significantly better. So we can even actually improve this more and more by trying to hyperparameter tune this. So I'm going to apply hyperparameter tuning on this. And if you don't know the basis of hyperparameter tuning, I have a tutorial explaining the different methods of hyperparameter tuning, grid search, random search, and all that. I have a whole tutorial on hyperparameter tuning, so feel free to check that video out. If I remember, I'm going to leave the link in the description, or I'm going to leave a card to show that. You can just click up here and get that, or I'm going to leave you can find it on the channel's main page. Okay, so whatever works. Okay, so once I have this done, I'm going to move on to hyper let me just get the spelling right. So hyperparameter tuning. So hyperparameter tuning, just here, and then run that code. So I'm going to say from sklearn dot model underscore selection. So selection, I'm going to go ahead and import the stratified this is going to be the stratified k fold, right? Stratified k fold, and the other one is going to be the grid search CV. Okay, stratified fold and the grid search CV. And this is going to be, I'm going to say parameters is going to be equals to the following. So I'm going to specify the number of parameters that I want to use. Well, again, I'm not going to explain what is hyperparameter tuning in depth in this video. I said I have another video explaining hyperparameters in depth, so you can check those videos out. So I'm just going to say criterion, right, and I'm going to pass in the following criterion values, and all these values can be found in the official documentation, and I went over all of this, explaining it in depth in the introduction to hyperparameter tuning video, so you can check that out. Okay, so in here I'm not going to go ahead and explain in depth about here. So number of estimators, we are going to be using number of estimators is going to use the following. So we're going to pass in a list of 10, 100, 150, 200, just like that. And also I'm also going to pass in the mean. This is going to be the mean underscore samples underscore leaf, and this is going to be equals the following. So it's going to be 1, 2, 4, 6, and then I'm going to pass in the max underscore features, and the max features is going to be equals to the following. So it's going to be auto. Okay, the max features, sorry for that, it's going to be auto, and then this is going to be sqrt, and then this is going to be log 2, just like that. So once I have this, I can simply run this. So I hope I made no typos there. Okay, so I'm going to create a k fold. I'm going to say k fold. We can pass in the k fold if you want. So if you pass in k fold, I'm going to say k fold, and the k fold is just going to be stratified k fold, and then you can pass in the number of splits. So it's going to split it into 5 different sections, and all of this I explain it in the introduction to hyperparameter tuning video, so you can check that video out. I'm not going to go ahead and explain it here. Okay, so let me just delete this all. Let's say the keyword and number of splits and not split, so run that. Okay, so once we have that, I'm going to go and say I'm going to have a classifier, and the classifier is going to be equals to grid search CV. Okay, grid search CV, and I'm going to pass in my random forest model that I want to use. So rand forest model that I want to use, and then I'm going to pass in the parameters that are specified up here. So parameters, I'm going to say parameters, and then I'm going to pass in the scoring. So the scoring is going to be based on accuracy. So accuracy, just like that. The scoring is going to be based on accuracy, and the number of underscore jobs is going to be equals to 2. And I can say the cross validation. The cross validation can be called the k fold. We're going to use the k fold for our cross validation. Okay, and again, all of this I explained it in my the introduction to grids hyperparameter tuning video. Okay, so you can check that video out. Okay, so once I run that, I'm simply going to go ahead and fit it based on the x train and the y train, and once that's done, that should return to us a couple of values. So we can do Once it's done, we can do classification dot get underscore params. That's going to show us all the params that you have used. So get params, and that should return to us all the params you have used. And grid search takes a bit of time because it's going to try this with all possible values of the other ones here. It's going to try this with all the other possible values of these other parameters right here. So it might take a bit of time. So let's give it some time to work on this. Yeah, so once this is done, classification is done. So we also wrote this code to get the parameters. So we can just simply run it to see which parameters have been used. So you can see all the parameters right here. Right. So now I want to go ahead and get the best. So I'm going to say classification report that best underscore params, and then underscore, and if you run that, that should return to the base parameters from all these parameters, right? The base one that was good for our classification model. So now we can use try to make a classification from it. So you can say classifier dot score, and then you pass in the x underscore test, y underscore test, just like that, and just try to get the score back. Okay, so you can get the score. You can even get the base score if you want. You can just do the base score of this one. You can do classifier dot it's gonna be best underscore score, and then underscore, and then run that. So be aware of the underscores at the end. So you can see they give us a score of around 98% or 98.3%, 98.3% accuracy on training, and for testing give us an accuracy of around 98.5%. So it's good, right? Our model is good. Yeah, so now you have those parameters. You can decide to go ahead and actually save the model if you want. So we're going to go ahead and actually save the one which you hyperparameter tune. You can specify more values here. Again, you can check that video out on introduction to hyperparameter tuning. I'm not going to go into depth explaining it in this video, okay, because it's just about building a classification model and just putting the idea of hyperparameter into it. So I'm not going to go ahead and cover that section, okay. So if you're interested, check that out in your own time. So I'm going to say save model is going to be equals to the following. So I'm going to go ahead and import pickle. We're going to use pickle to save. So we're going to import pickle, and then run that, and you're going to say with open this is going to be model dot pickle, right? Model dot pickle, and then pass in write binary wb as model underscore file, okay, model file, and then simply do pickle dot dump, and then simply pass in the classifier model, and then the model underscore file that we want to save it, and then run that. So once we run this, our model should be saved, and you should be able to get the model right here. So let me see where you can get the model. So these are just I think you can get it from here, and you can go to model pickle. Let me see which part here you can get it from. I think it's here. So let me just open up this. We call it model.pickle. Okay, sorry, it's this one right here. I'm just checking something else. So it's this one right here, which is the model that you're interested in. Sorry, I didn't see that earlier on. So this is the model that you're interested in. You can go ahead and download it and use it for you can build a web application around it and do something with it, like actually build a whole project using web application, whereby the user have to pass in the parameters of that employee, like the employee salary, the experience level, and all that information, and you can then do some pre-processing on that data that they give you, pass it to the machine learning model, which you have already saved in this here, and then simply be able to make predictions. Okay, so if you guys were interested in us building a full application on this, let me know in the comment section below. We can do that using Flask, or we can use we can even build an API using Fast API and something like that, or Django REST framework or something like that. So yeah, that's all I wanted us to cover in this tutorial. So if you guys enjoyed so far, make sure that you like the video, subscribe to the YouTube channel, and share this content with anyone who you think might find this helpful. So thanks for watching, and see you in the next one. Keep safe.